Time is a weird construct of humanity. It's both something external from us, but also something extremely internal. If we focus on it, it slows down, but if we forget about it, it speeds right past us. We keep reaching for more time, more opportunities, but the harder we reach out, the more it seems to slip away from us. As a programmer, I've had to deal with timings in the nanosecond, or 1/1 billionth of a second. Our brains work at a much slower rate, at 1/10 of a second. Why? Why does time matter so much to us that we measure it faster than we can think? Why? As with most human habits, we need to look to the past, specifically around the time that humanity created agriculture. You see, farming is a tricky job, especially when it comes to the seasons. If you plant your crops too early in the year, you risk the young sprouts being killed off by frost. However, if you plant too late in the season, you also risk any unripened produce being killed off by frost when fall comes around. Ancient societies noticed this, and they devised different ways of tracking this. The ancient inhabitants of England constructed Stonehenge, which is believed to line up with the solstices and other important times of the year. The Aztecs and Mayans built pyramids and great temples that would mark specific days through the patterns created by the shadows, such as a giant snake slithering down the steps. Individual time mattered as well to the ancients. The Shango bone is a bone with specific notchings carved into it, and some archaeologists believe it may have been used to track the lunar calendar, as there are several groupings of 28 notches. The sundial was society's first attempt at tracking individual hours. The first sundials we can find were back in ancient Egypt, dating as far back as 1500 BC, and we still use sundials today. The Mars rover has a sundial. Scientists use it as a way to help determine the exact position of the rover based on the shadow's angle when the image is taken. Now, we obviously don't use sundials widely. After all, you don't see anyone going around with a sundial strapped to their wrist. So, how did we get to this digital age of timekeeping? The answer, funny enough, is water. The first true clocks that tracked time were the water clocks. Once again, the earliest examples we have found were in ancient Egypt. These were simple ceramic bowls with holes in the base and notches on the inside to determine the hour. They weren't very accurate, as precision measuring using clay is tricky since pottery is more of an art than a science. Then why were water clocks used widely until the 17th centuries? We have the Greeks to thank for that. Ctesibus was an ancient Greek inventor who perfected the Ctesibus, as the Greeks called it. He iterated upon the device several times, the first of these iterations involving a second container. Now, the first container would empty at a steady rate, and the second container would fill up to create a more accurate representation of time. But he quickly encountered a problem. Now he had to regularly empty a container of water to be able to tell time. And what if he wasn't paying attention or was running a little late? He probably had to rush home several times saying he had left his water running again. It was likely annoying enough that he invented the siphon to refill the first tank when the second one was too full. Now he had the first ever self-winding clock. This was perfect. What could possibly go wrong? The Greeks. That's what went wrong. You see, the ancient Greeks didn't measure time consistently. They broke up the time from sunrise to sunset into 12 distinct hours. Now, this doesn't seem like a big problem, as that's how our time system is set up. However, the problem is that the length of the hours changed based off of how long the sun was in the sky. Thus, in summer, they had longer hours, while in winter, they had shorter hours. So Ctesibus inventing a clock that consistently gave the same hours at regular intervals was an actual problem, as his working clock was only right twice a year. So what did he do? Did he give up? Throw in the towel? Not a chance. He incorporated mechanics into his clock. Behold, the most accurate clock of not only its time, but for the next 2,000 years as well. This beauty of engineering not only incorporated what Ctesibus designed in his earlier clocks, but included a water wheel that would spin this cylinder here. Now, it didn't spin very quickly. In fact, it took a whole year for it to make one rotation. And these hoops on the outside represented the hour as it changed from day to day. And this little guy here would point to which hour it currently was. Now, he sat in a tube that would also steadily fill with water, slowly increasing his height so he could proudly point at the current time. Since Ctesibus's water clock was the most accurate clock for almost 2,000 years, it wouldn't be hard to imagine that there wasn't much innovation in the field. And that sentiment is partially correct. There weren't many major changes added to the basic design, but that didn't stop small tweaks here and there. Now, the main issue with the water clock was one that Ctesibus probably hadn't known of, and that was freezing. Now, Greece is in the Mediterranean, and they only have 3 main seasons there: spring, summer, and fall. Most of Europe was not so lucky, so their water clocks would freeze about half the year. The next major innovation was the introduction of mercury, or quicksilver, instead of water. Mercury wouldn't freeze as quickly as water would, making it an ideal substitute. In fact, Ismail Jazari from the Middle East created many clocks using mercury, including one of an automaton elephant. So if water clocks worked so well for over 2,000 years, why did we stop using them? You see, behind the scenes, many inventors attempted to make a clock that didn't require liquid to operate. The first of these mechanical clocks most likely showed up in the 13th century and used weights as a substitute for water. It would mostly be used to ring church bells used to indicate the hour. These clocks were most likely extremely inaccurate and would need to be regularly reset. The next major development in mechanical clocks was the introduction of the spring. The addition of the spring to the clock is often attributed to Peter Heinlein in 1511 AD. However, we've now found springs from clocks dating back to 1430. The spring was a wonderful new power source for clocks, as now a person didn't need to worry about resetting heavy weights or refilling their clocks with water. It did come with a drawback, however. The more undone a spring becomes, the less power it can deliver. In response, clockmakers invented parts that are still used today in mechanical clocks: the Stagfried and the Fusee. These 2 devices, in tandem, reduced the force of the spring when it released excess energy, and then compensated for any lost energy later on. Now, despite all these innovations, water clocks were still more accurate than mechanical clocks. Springs were now releasing energy more consistently, though clocks would still drift away from their established hourly rhythms. There was still variation that needed to be eliminated. They needed something to truly regulate their movements. And what better regulator than the Earth itself? Originally conceived by Galileo, the pendulum clock would rely on a large mass swinging back and forth. The already swinging pendulum would receive nudges from either the springs or the weights, and thanks to gravity constantly pulling the pendulum back, it would swing at a constant pace. This would set the pace for the rest of the clock, which would receive its energy in time with the pendulum swing. The first of these clocks was built and designed by Christian Huygens, who even figured out the specific length the pendulums would need to be to swing at exactly 1 second per swing. For the first time in history, machines regulated man's life. Business owners could now accurately determine how long an employee had been working and paying them only for their exact time. Factories relied heavily on this, ironically many of them mass-producing clocks themselves. Man was now shackled to an extent by his new discovery, but it also freed him. With accurate timepieces, scientific innovations were discovered. Processes that needed to be consistent with timing were now possible. Trains could consistently run on the same track and not worry about running into one another. People could see when a train was supposed to arrive and then gripe about that fact that maybe it was 2 minutes late. Yes, we had restrictions, but we gained far more than we lost. Society went with this new beat, established in 1657, for roughly the next 250 years. We'd conquered the seconds of our lives. What more could we need? But that's the thing about humanity. We didn't stop at days, hours, or even minutes. We had to gain a complete understanding of our world and how to impact it. But what about the stars? The problem with pendulum clocks is that they rely on gravity and stability. We've known for a while that pendulum clocks don't work on boats. And as we began to fly in the early 20th century, we realized how much of a shackle gravity really could be. Our world was growing and shrinking at a rate the pendulum couldn't keep up with, especially as we set our sights to the stars. The solution to this issue was a pretty little rock that wasn't bound by gravity: the quartz crystal. Quartz has a unique property. When fed electricity, it begins to vibrate at an extreme but consistent pace. Scientists at Bell Telephone Laboratories noticed this property and created the first gemstone-regulated clock in 1927. Quartz hums at a consistent 32,768 times a second. And dividing such a high frequency into clean, accurate time signals wasn't simple at first. J.W. Horton, the inventor, was soon able to perfect his clock, and he set the standard of time for the next 30 years. This was great. It was amazing. Clocks were now easier to make, making them cheaper and more widespread. But it wasn't enough. As we moved into the age of electricity, the regulation of said electricity became more difficult. Electricity, for all intents and purposes, moves at the speed of light. Sure, we could now measure the millisecond, but light travels 128 miles in the span of that time. It would be like regulating trains based on the day and not the minute. The solution we came to was all the rage at the time. It was atomic. Atomic clocks are not an exclusive idea to the 20th and 21st centuries. They were initially theorized in the 19th century by Lord Kelvin. Now, this is the same Lord Kelvin who created the temperature scale that starts at 0 movement by an atom. The thing with atoms is that they're always moving, always spinning. They don't rely on gravity or electricity to move them. They do it because that's how they are. Imagine setting time based upon the fundamental building blocks of our universe. Something that would work no matter where you were or how you're using it. The US National Bureau of Standards managed to bring this theory to life in 1949. Sort of. It turns out that counting the rotations of the very elements is extremely difficult to do. It wouldn't be until 1955 that Louis Essen would create the most accurate clock of the time, the Ctesium clock. It's so accurate that it won't miss a single second for over 1 trillion years. This was it. Now we had the precise control over time that we required. Now we could utilize electricity to its fullest potential. Innovations quickly came in. We created calculators the size of a room. We sent a man to the moon, and we did it again and again. We used magnetic strips to record life at a steady rate, and then we abandoned that and started using electricity itself. In the past, special clocks had to be developed to help navigate the globe. Now we have maps of the entire world in our pockets, and they guide us to our destinations down to the last second. All throughout history, we've relied on time. We nurtured it and we domesticated it. Through its taming, we were able to tame more of our world, from agriculture to the very elements themselves. We went from measuring seasons to measuring picoseconds, and yet, despite that fact, time still slips away from us, second by second. But maybe that's the point. Maybe that's what made us human. Not that we count time, but that we care enough to try.